Alright, so we're doing number 3 now, and the instruction on the answer is find the terms of it. Alright, and then simplify the answer. So we want to break this down. Whatever we get, we want to break it down as simple as we can. Alright, so number 3. So forget all the others.
Sorry, we're not normally 12. We
Take them off for your face. Sorry, I can't slide this up. Nice smart with it. So, let's just write this back up here. So the sum from 1 to n of, can we just distribute this right now?
Yes.
What would it be?
R cubed
R cubed
plus R squared.
2r squared. So I can
R squared.
move this from here. Alright, so was it r squared plus
No, that's right.
2r in bracket? Okay. Alright, so we're using those exact results now and then try to simplify this expression. So we know we can break this apart. So it's going to be step by step from 1 to n of our r cubed plus 2
sigma.
1 to n of r squared. So we know we're comfortable with that. Everybody follow that, right? And probably next time you can change this. I'm going to be lucky, especially from this side. You can move this here. Alright, so what's the result for this one? It's on the board. N squared plus, sorry, bracket n plus 1 r squared over
4
plus 2 and then
n plus 1
n times n plus 1
plus 1
to n plus 1
over 6.
all over 6. Alright, so we'd love to just stop there.
Sir, I thought you would have to you'd have to
But the question says simplify. So we can't solve this one because we don't have some different input.
Because I saw the example they used 12.
Yeah. But now we don't have a set n value. So what we have to do is find out to combine this into just one nice expression. So, what can we do? What are some of the things that we've done in think back to induction, or we simplify induction? We use certain little things that we talk about. Common factor. If you have two fractions, what are some things you want? Have the same denominator. So these are the things that you can do. And simplify, reducing fractions if possible. Very good. So all of these are the things that we're going to be using to break this down. So first things first, let's get this to out here because these are still not the same. So even if I can carry this down to 3. No, I still want to get 12 with the same denominator, right? So what can I multiply? What should I multiply this one by? So if I multiply by here, so by let's say 3, I get 12. Then I have to multiply by here, so by 4. But now you have to maintain the integrity of the expression. You multiply the denominator by a number, you have to multiply the numerator by the same number. So it's times 3 there. So we use over here, we have to multiply up top here by 4. So after we cancel them. So now everybody's over 12. It's good. So what did I have? I have 3n squared times n plus 1 r squared over plus 4. And I could bring this in now, because this is a product. So it could be 4n bracket n plus 1, 2n plus 1 all over 12.
Sir, if I can ask, because you've just done it up
I could have drawn one line up to the bottom of 12. Was that what you're asking?
If you just do it up part and left it, but then just.
Hold on. What is it? Don't forget.
So you just done it like they just left it.
If I stop here?
Yeah.
Yeah, you'll have to lose on some marks. That's not simplifying it. That's stating it, not simplifying it.
Go ahead, please.
So now when you have adding two fractions of the same denominator, you can just bring all them under. Just add the numerators, right? So next thing is just to add the numerators. So it's going to be 3n squared n plus 1 all squared plus 4n times n plus 1 2n plus 1. And now everybody's over. So now we have one fraction almost, or we still can probably simplify the numerator a little bit better. Right? So think of it. Good. Let's see. So these are like those two terms. Can we look at them separate? I don't want to factor anything common. What's any common factors there? There is.
Over here plus 1.
Between the two brackets.
N plus 1.
What's n plus 1? I can get n plus 1 here. I can get n plus 1 from that term. Anything else I can get from? What about the n? N and the n plus 1. Couldn't I get those? I can have n times the n plus 1 to this bracket. I can have n times n plus 1 to that bracket. Right? So let's see what we'll get if we do that. So if I factor out, so I'm going to factor n times n plus 1. So, one in here and one is n plus 1. What is going to be there? So I'm going to have n times n plus 1. What's going to be on the inside? Oh, I can take out the 12 too. So now I'm going to focus in on the numerators. Yes? So, from here there's going to be that 3.
3n plus 1.
3n and times up.
N plus 1.
N plus 1. Everybody see that?
Yeah.
Tell me if you see. Just take it out 1n times 1 is n plus 1. There's 2 of them here, 2 of them here. Right? Good. And then, so for the next term, plus. So this and this gone. So that's 4 times that, right? 4 bracket 2n plus 1. Very good. But is that?
Yes.
And now what we have to do is just try and simplify inside here. Right? So, this expand is what we get. That's 12n squared plus 3n. And then this is plus 8n plus 4. And then we can group like terms, right? So this is going to be 12n squared plus 11n plus 4. We can stop here. 12 4 is 48. Is there any two numbers that multiply 48 and add to give you 11? 12 and 4. 8 and 6 now. So leave that. So a final answer. Unless you can factorize this down to product of two terms, it would be n times n plus 1 times 12n squared, then n plus 4 all over 12. And we can do this because it's just one big product. Right? So all this will be over 1. So if you multiply two fractions, you multiply numerators, you multiply denominators. So don't be confused how I go from that to that. Or go from this to that. Same way how I was able to pull it out, I can multiply and it just goes back. Do you see it? So if I take a fraction, so all this would be over 1. Think of it like that. So I multiply numerator with numerator. And then 12 times 1 is the denominator. See it? And when you write it, when you multiply algebraic, you just put them in brackets. Everybody see that? So n plus 1. N times that.
Yes, sir. How you going to treat the 12 and cube again?
Or it shouldn't be 12.
Oh, yeah. Try.
That's supposed to be 3. Okay? Where did 12 come from? Come on, it says 3n squared. 3n squared. 8n. Oh, no, that can factorize. Huh? No, not. Because 3 times 4 maybe can factorize. 3 4 is 12. Which two numbers multiply to 12 and add to give me 11? No. Obviously 12 by 1, but I'm going to subtract. Okay, so we just have to add that bit in. So it's going to be what? 3n squared. That's it. 3n squared plus 11n plus 4. So this can be factorized. So we do that. I have no idea what to do. How long is that? 9 minutes, okay.